Okay, 1.7 course practice quiz. Very very easy. We shouldn't be longer than 10-minute video. Okay, عندنا a table with the coefficient of thermal linear expansion, whatever. uh, يعني these are all their alphas. Okay, يعني the for the linear expansion, the formula is delta L. I'm not gonna erase this, I'm gonna keep this at the top. Delta L equals alpha L initial delta T. Right? Remember this equation, we're gonna keep it at the top. Okay, we have all the alphas here. Question 1: in order to make a thermometer with the largest bend for a given increase in temperature. Remember, when you heat a rod made up of two metals, it's gonna bend in one direction. Let's say if you heat it up, it's gonna bend in the direction of the lower alpha. Okay, this was in the notes. Go back to the notes if you still haven't watched it already. Okay, I explained it very well. Over here, you see, when you heat, you cool, whatever. They want the thermometer with the largest bend. The largest bend means that it bends the most. That means the difference between the two metals is the greatest. If there's no big difference between the alpha of one and the alpha of two, then what's gonna happen? There won't be a large bend, right? It's just gonna be like a small tiny part. Since we want the largest bend, we're gonna put the greatest difference between them. So okay, we're gonna have the largest alpha and then the smallest alpha. So aluminum and iron. ماشي. Part B. If strip 1 is made of silver, then what is strip 2 made of? Let's see. Here they said it got heated and it bended upwards, right? Towards the silver. So here we're saying silver. They said strip 1 is made of silver. If it's heated and bending towards silver, that means, remember, it bends towards, when you heat it, bends towards the one with space. So remember, it goes like this. And this one, there's space here, since it didn't extend as much. So that's why it bends upwards. Remember? Okay. So that means silver had the less alpha. So from this table here, silver has less alpha than what? It has less alpha than aluminium, right? So the only possible one that metal 2 can be is aluminium. Question 2. Calculate the thermal expansion. Okay, here we need to use the formula. I don't know why I erased it. Delta L equals alpha L initial delta T. Okay, so let's see. Aluminium rod whose length at 0 degrees Celsius is 1200. So L initial is 1200. Okay, is heated to a temperature of 80 degrees Celsius. So it started at 0, it finished at 80. So yani delta T is 80. Okay. The coefficient of thermal linear expansion is 24. Okay, so 24 is my alpha. 24 times 10 to the negative 6, huh? Okay. And then we want to find the final length. So let's equate it to delta L, which we know, sorry, not delta L. Delta L, is L final minus L initial. That's what delta means, final minus initial. Okay, let's solve this. You're gonna get 2.04 or something like this. Okay, 24 times 10 to the negative 6 times 1200 times 80. 2.304. Yeah. So you're gonna get L final minus L initial equals 2.304. طيب, what was L initial? 1200, 1200. So L final minus 1200 equals 2.304. Okay, which is we can find that L final is equal to 1202.304. They want it to the nearest integer, so 1202. Question 3. Coefficient of linear expansion of copper at 20 degrees Celsius is 17 times 10 to the negative 6. What is the coefficient of surface expansion? Surface يعني أصلا area. Okay. What's the coefficient of the volume? Volume. If you remember in math, area is square, volume is cube. In physics, to change from linear to area to volume, here's what you do. I literally just figured this out now. It's 17. Area is square. So what do? You multiply by 2. 17 times 2, 34. Volume is cube. So what do you multiply by? Times 3. What do you get? 51. That's it. أكيد the times 10 to the negative 6 but it's already written I'm not saying it. Question 4. A bimetallic strip is made up of copper and aluminium, both of length 62.8 and 0.1 millimeter thick. The coefficient of thermal linear expansion of copper is 17 and that of aluminium is 24. Fill in the blanks here to know which one is aluminium, which one's copper. So they heated it and the strip bends into a circle. They heated it so much that it became a circle. Okay? Akid, here we have an outer circle. Akid, the outer circle is the longer one, with the inner one is the shorter one. Right? Okay, longer. طب أكيد the one that's longer has the greatest alpha. And which one here has the greater alpha? It's 24. So 24, which is for aluminium. So يعني اللي برا, the one outside, is gonna be aluminium. What's gonna be the one inside? Copper. Okay. Question 5. Here they said that the solid sphere cannot fit. So what would you do, Akid, to make it smaller? We're gonna cool it. Why would you cool it? Because when you cool it, it shrinks. So then it can finally fit through the hole. Question 6. You have to know if it's a good or poor conductor. Liquid mercury, we said, is the only exception to liquids that is a good conductor. Copper is a metal, for good conductor. Fiberglass is not a metal, poor conductor. Iron, metal, good conductor. Water vapor, poor conductor. Remember, water is a very poor conductor of heat. Okay, what contains free electrons? Good conductor. If it contains confined electrons, confined yani it's not free, yani it cannot move, yani poor conductor. It's in a gaseous state. Okay, gases are very poor conductors. Contains pocket of air, poor conductors. We said air is a very bad conductor of heat. Is a metal, أكيد يعني it's a good conductor. Question 8. By the kinetic molecular theory, the heat transfer by conduction occurs when the faster moving molecules in the hot parts collide with what? With the slower moving molecules in the colder parts. What happens when they collide? Poof. They transfer to them a part of their kinetic energy. So the fast ones transfer some kinetic energy to the cold ones. Okay, here I need to make this recording 8 minutes long, and I need 45 seconds, and this is a very easy question, so I'm gonna take my time reading this. The picture below here shows an experiment used to compare different metals. Okay, you have copper, iron, aluminium, and brass. 4 matches are waxed on one end. This is the key word here. And I got this wrong because I didn't read it properly. Are waxed. Okay, so they connected this match by wax over here. Okay, on 4 different metal rods while a Bunsen burner heats the other end. Remember, this was one of the experiments we did in the notes. Yeah. How can you tell which metal is the best thermal conductor? Is it the one that lights the match first? أكيد لا. We're connecting it with wax. And what happens when you heat wax? It melts. So the one that's the best thermal conductor will melt this wax first, thus causing the match to fall on the ground. And which one is that? It doesn't matter. So it's gonna be the one that which one's the best conductor? The one that loses its match first. And if I'm not wrong, it should be copper. But don't take my word on that. You don't need to know that anyway. So the best thermal conductor is the one that loses its match first. Is it 8 minutes? Yes, we are on 8 minutes. Thank you so much for watching, and good luck.